Trigonometry. Just hearing that word probably gives some of you flashbacks to high school math, right? All those complicated formulas. But what if I told you we can explain the whole thing, I mean everything, with just one simple shape? Let's dive in.
Yeah, sine, cosine, tangent, these words just feel like a bunch of abstract rules, don't they? Well, let's just forget everything you think you know. We're going to start fresh, from square one, and build it all back up with a single, elegant shape that, believe it or not, holds the key to everything.
So what's our secret weapon? It's called the unit circle. Now I know that name might sound a bit formal, maybe even a little intimidating, but trust me on this one. It's one of the simplest, most beautiful ideas in all of mathematics, and it's the foundation for everything we're about to uncover.
All right, let's build this thing from the ground up. Forget formulas, forget triangles, forget everything. We're starting with the most basic shape there is. Yup, just a circle. That's it. See? A simple, hand-drawn circle. Okay, now let's give this circle an address. We're going to place it right on a graph with its center sitting perfectly at the origin, at 0, 0. And now for the most important part, the one rule that makes all the magic happen. The radius, that distance from the center to the edge, is exactly 1. Just 1. It's not a random number. That choice, the number 1, is the secret ingredient that's going to make everything else just click.
And voila, that's it. That's a unit circle. And it has this one super elegant rule that comes with it. For any point you pick on the edge of this circle, its x-coordinate squared plus its y-coordinate squared will always equal 1. Just remember that little equation, x squared plus y squared equals 1. We're going to come back to it later, and it's going to be a really cool aha moment.
Okay, so we've got our circle, it's perfect, but it's kind of just sitting there, right? It's not doing anything. Let's bring it to life by adding the one thing trigonometry is famous for, an angle.
So picture this. We draw a line, a radius, from the center straight out to the edge. See how that line creates an angle with a flat horizontal x-axis? We'll call that angle theta. That's just the Greek letter mathematicians love to use. But really, you can just think of it like a knob or a dial. You can spin it all the way around the circle.
And wherever we stop turning that dial, that line touches the circle at one specific spot, right? A point. And that point has an address, an x-coordinate and a y-coordinate. But, and here's where it gets really, really cool, those x and y values aren't just coordinates. They're something much, much more.
Okay, get ready for it. This is the big reveal. The secret that makes all of trig make sense. That x-coordinate of the point, that is the cosine of the angle. And the y-coordinate, that is the sine of the angle. That's it. No complicated formula to memorize. You just look at the coordinates. Cosine is how far you go sideways. Sine is how far you go up or down. It's literally right there on the circle.
I know what you're thinking. That seems a little too easy, right? It feels like a magic trick. Why in the world is the x value just magically the cosine? Well, it's not magic. Let's pull back the curtain and see exactly how this works. It's actually incredibly clever.
And asking this why question is the difference between just memorizing facts and actually getting it. And the answer, well, it's going to take us on a little trip down memory lane, back to something you definitely saw in geometry class.
Remember that crazy word, SOHCAHTOA? Yeah, that one. Well, check this out. What happens if we take our point on the circle and just drop a straight line down to the x-axis? Look, we've just drawn a perfect little right-angled triangle hiding right there inside our unit circle.
All right, let's blow the dust off those old rules. SOHCAHTOA tells us that cosine is the adjacent side divided by the hypotenuse. Okay, so in our little triangle, the adjacent side, the one next to the angle, is just our x distance, right? And the hypotenuse, the long slanted side, well, that's our radius. And what did we decide our radius was going to be? Exactly 1. And here it is, the payoff. Cosine is supposed to be adjacent over hypotenuse, which for us is just x divided by 1. And anything divided by 1 is just itself. So cosine is just x. And sine is opposite over hypotenuse, which is y divided by 1, which is just y. That's the whole trick. By making the radius 1, we made that whole divide by the hypotenuse part of the formula just disappear. So elegant.
Awesome. So sine and cosine are totally demystified. They're just x and y on a special circle. But what about the other one, tangent? Well, the great news is, since we've already done the heavy lifting with sine and cosine, tangent is going to be an absolute breeze. The most basic definition of tangent, the thing you have to know, is that it's just a ratio. It's simply sine divided by cosine. That's it. Tan of theta equals sine of theta over cosine of theta.
So let's think about this. We already know that on our unit circle, sine is just y, and cosine is just x. So if we just swap those in, what do we get? We get that tangent is simply y divided by x.
And this is so cool, because it tells us what tangent actually represents visually. Think back to your algebra classes. What is y divided by x, or rise over run? That's the formula for the slope of a line. So tangent isn't some abstract concept. It's literally just the steepness of our radius line. How cool is that?
So let's zoom out for a second. Why did we do all this? Why are we so obsessed with this simple little circle that has a radius of 1? What makes this idea so incredibly powerful?
Well, think about it. Triangles are great, but they get really weird once your angle goes past 90 degrees. You can't have a triangle with a 180-degree angle, right? But a circle just keeps on going. It loops around and around forever. This is why the unit circle is so amazing. It lets us find the sine and cosine for any angle. 360 degrees? No problem. 1,000 degrees? Yep. Even negative angles. It's the reason sine and cosine create those beautiful repeating wave patterns you always see.
Look, if you walk away with just one thing today, I want it to be this. Forget all the formulas for a second and just picture that circle. Cosine is your left-right position, sine is your up-down position, and tangent is just how steep the line is. Left-right, up-down, steepness. That's the core idea.
And now for the grand finale. Let's bring it all back home. Remember that very first equation I told you to tuck away? X squared plus y squared equals 1? Well, what did we just learn? We learned that x is just a fancy name for cosine, and y is just a fancy name for sine. So what happens if we swap them into that equation? We get cosine squared plus sine squared equals 1. You've probably seen that famous identity before. It's not some random rule you have to memorize. It's literally just the equation for a circle. See? It's all connected. It's pretty amazing, isn't it? That one simple decision, just make the radius equal to 1, it completely unlocked this entire beautiful branch of math. It really makes you wonder, what other incredibly powerful ideas are out there, hiding behind something just as simple, waiting to be discovered?